Okay, so what I'm doing is this is like upside down. Let me turn this up. This is supposed to be the other side. It's actually, it has to cure. So I poured the resin onto the brick layer. As you see, I didn't want to get the edges, even though I could have assembled them all the way down and cut the edges, but that's okay at the bottom of the show. It's still satisfied. It's still curved. So I just put the resin on there to settle. And I have a little bit more that I'm going to add on top. And here, right here, I have the coil, and I applied the brackets. These are guide brackets. And I have the two simple guides to run with an articulated joint that I'm using on both sides. So I added that on. Notice how I placed it down by the short segment, down by the knee segment. And what I'm going to do is cross this over. Oh boy, it's playing. And I'm going to add more whiting coil. I have more iron coil, so I'm going to spun it around to continue the circular of magnetism and spun it around there. And just make as many as I can in sets. And then what I'm going to do is, I'm going to phase the phase wires and bust them into a junction. I have a plastic Tupperware that I'm going to be using to encase it into the resin so I can reside it somewhere. I'm going to try to leave the cabinet or the door open to it so I can at least access the modules that's going to be fixed onto the resin. So I got both of the guide brackets here, and this is the slide knee. It's going to be folded up an articulated joint arm, and it's going to move forward. The latch is going to be here to the metallic latch is going to attach to the knee and then zigzag form and fold down. This servo is just going to be bucking at it. So I'm going to have an electromagnet here so I can detect the articulation, the movements, the access of the servo. However, it's just going to be coupled by a metallic bond. The magnetism to oscillation, the movement will be done by between the thigh and the knee. So the phase of the electromagnetism of it moving vertically or horizontally. However, there's going to be, the kneecap is going to have a guard so it can't flex all the way out like that. So it's going to be locked in. It's going to be a locking system to zigzag into locks this way. So that's just going to be part of here so that extend the arm. Now the other part of the warping will be done by the pancake motor right there. And I'm going to harden it, so the resin is going to harden the bracket. So I'm not worried about the density of that because I can still overlay it with resin and other different high viscosity or density metals of the aluminum bracket. And that's it right now. So it's just I'm going to wind a coil over it, the iron coil, increase the flux, and let that cure and dry the permanent magnet wool. And that's going in the back of here. So as that shape goes out here, it goes in here into the cockpit area at the bottom. So that will phase it to move it backwards. So to the magnetic suspension that hold me in a horizontal plane position in space. And also the lineary motor that causes me to move upward in the linear motion in space upward. So I have the proximity for vertical stabilization to not pitch to the forward, and the back of the thigh to not pitch to the back, so keep using a proximity hold. And because of the curvage, causes it to curve. So if I shift the pitching axis to side, it is still guided by the two pairs that loops around like eddy currents. And these two will force it back into vertical position, stabilization. So my name is Jermaine Morton, and goodbye. Okay. So what I did was I added the magnetic flux. Notice how I put the magnetism, or the ferromagnetic wire, the stainless steel. See how I put it in circles, like coils, or the coils underneath. It's local to the edge side, so I got to put the series in here. And notice I have the series of coils, so I'm going to tie a nickel neodymium around each one. And I'm embedded in before I even coat this. So I'm unscrew the brackets, which I'm going to use for the articulated arms. Let me bring the articulated arms to show you what they are like. Okay, I'm just going to show you what a pair of articulated arms. Here's two of a pair. These will join together like a articulated arm, and I don't have them screwed in together as of yet. You can see here, this is a slide guide. It allows it to shift back and forth the magnetic field. Remember, this is paramagnetic type element, so this is aluminum, and it would actually move naturally. As soon as a flux returns to the system, this will extend out away from the frame. And while it moves up and down, it will also push the knee. Notice how there's one jointed area for the knee. That's all that's needed. For the armature, then, underneath it. So what I'm going to do is I'm going to sever this down a piece a little bit. And that will allow the armature that I have here. So I'm going to face this servo the opposite way. So I can enable the arm, because I don't have to actually, but I have to actually, to face this servo and hub the opposite way so that when it turns, it will be facing out this way. So I'll have the lever to grip directly to the bottom of the kneecap and to pull the kneecap back and forward. So this would actually be jointed to the bottom of the bottom of the kneecap. This will be jointed to the top, but the bottom of the kneecap will be pulled by the hub in a long flat bar that will be localized right here by the kneecap. So while I'm finishing these irons so I can flux the density, I'm also going to probably put a permanent magnet and copper on here, so I can actually have it fly real hard strengths down there. I probably won't need it, but I'll just try it anyway. And there are the screw points and the articulator, so it has a pitch come out a little bit, so I don't have to have it, And I can also fold it, because I have two here. So I can slide them back into or allow it to fold back. And I can put a spring to one and another. Like I also have one here so I can lock it in the other way. And use one to articulate to actually be joined together like two pieces as a joint area, elbow joint. And that will allow the kneecap and the thigh to slide up here and then fold down. So doing that kind of segment. I know I could do the Iron Man segment with the brass rings. Remember the brass rings? And cause the brass rings to fold down assembly with a coil in between each brass ring. Now I can make it separate and put it on tracks like that and have it slide down and connect together. I can have it open up and close together through a latch segment. So it's kind of easy. My name is Jermaine Morton, and goodbye. I hope you like the part that I'm finishing up. Okay, so notice how I have the thigh. This is the hip rhombiaxial thigh part area without the knee. This is the permanent magnet wool that I'm making. This wool shall be behind this coil in the copy area. I put foam right here, and I just allowed the foam to be extended. What I did was I also added the foam so that it will stick the magnet part on there. Notice how it's curved and shaped to the segment. The sparkles are because of the resin. So I added the resin to coat it, so I make it in a solid state. I'm gonna do another coat after 24 hours, and I'm going to apply it to the back inside the cockpit. And this is iron that's going to be magnetized. Notice I have a large gauge. The reason why is so that when I do incorporate the parts on the segment, I still want to give it a squeeze so that I may bend it and deform it into my metric range. So I still want to inherit that into my segment. Now, as far as one of the things I'm going to be using is an inductive fan. And that inductive fan is actually a vacuum. And it's a small vacuum fan. I think it's about 30 inches, 30 millimeters. And I'm going to add that to the system so I can just keep it cool. And I might add coil and tubicles, spiral as far as tubicle aluminum. And I believe that if I add the connections to a pump in any freeze, I can maintain and keep it cold. So that happens. That I think fixes the heat situation. Here is where the magnets will be, where we ground the electrical magnet. And I can also use, I'm going to be using foam in the back of that. And then I'm going to be using a compound mixture. So I might as well get ready for it. I think that the compound mixture I'm going to be mixing with is foam, and then I'm going to overlay it with some jelly, PVC transparent jelly. And the jelly sheets is going to be fixed across the other side, mounted on the other side, and I'm extending the edges like something like this, but a little bit longer. And what I'm going to do is curve the ends with a heat gun. And of course, the focus like be the other way, like a horn. Sway it to keep it, like a horn in the central area, so that even though this is small, it fits in the larger area. So it's going to be like a suction horn. And I plan to use glow-in-the-dark compound powder. And the glow-in-the-dark compound powder, I'm also planning to use flat silver wire. And the flat silver wire, I'm going to junction it to small capacitors. And that's going to add like a photovoltaic. So the glow-in-the-dark, along with the photovoltaic, which is needed, necessary. So I'm going to be using yellow diodes along with the blue diodes. The electrons in the blue diodes will also enhance the yellow diodes because I'm using it for the Doppler effect. So even though this will react as a horn, I'm going to be using it for a Doppler effect. However, driving it by an AMG STI. I'm going to be using like a sodium acidic. This is for ion sensory. So I'm going to try to modify the circuit so that it may detect my bioplasmic electrolyte potassium sensory more with the light, inductive light, using a yellow light diode, induction light, magneto induction light diode. And I'm going to be using that as a horn to the Doppler effect. And that will assist, so in the back of here, along with the magnetic microwaves. It's going to be using low delta frequency, low delta or beta waves, low delta or beta waves. Now, the fabric right here that I have, like, it's not a fabric, it's actually a carbonate, like paper, like foam. And this is unique. I like it because it's neat and it floats. So when I found that it floats, it's actually when I drop it, it has a long time journeying to the floor. So therefore, that means that it's blocking low microwaves. And that would be good for when that would be good for when using for hang tie and also for repulsive force. Because I don't want the force to actually move. I don't want the microwaves to move through me, but I want it to be blocked in some measure. So where they reach the magnetic field effect of the permanent magnets and repel away from it. So the idea is to get this type of horsepower torque, which is more magneto force, polarized magneto force than this permanent magnet, and to move the permanent magnet in the compact backwards. So as it moves backwards, it will force me over to a horizontal position. In the horizontal position, when I face it down or at a pitch, the magnetic suspension will hold it up, so it can fix on access to a vertical position. So this is why I have a series of solenoid or Hall effect coils to move upward. And this is why I put also a series of lineary. So I'm going to also make a series of coils at central all the way to close that part so it's not really visibly seen. So this I'm going to be making a magneto. Like I said, I'm also going to be phasing these wires with permanent magnets. So I'm going to continue the oscillation because as magnetism will flow and magnetize, it will magnetize the circular and not just the ion line. So my name is Jermaine Morton.